as we take a look at question number 12. So in number 12, the question said that we are looking at, first thing we want to do is copy above the problem, identify this is my x1 and this is my y1. Okay? This is my x sub 2. So x sub 2 is what value, if I was asking you, Erin, what would you say? X sub 2 is what value up here? Look in your book then. Look at your book then and put right above this, write this x sub 2 and tell me, what would your x sub 2 be? What number? isn't it 5.65? Can you see it in your workbook? Yeah, okay. So, do you see where I have x2 written right above this? Okay, so then Maddie, if I was looking at y sub 2 is what number? Negative 3.5. So what I need to do first in number 12 is I need to write my slope formula. So I am going to start with, Kyle, you remember the formula? You have it written down for me? Yeah. Okay, go. If you did not have this done, make sure you write this formula down and do this problem with us. If you did not have 12 done, this is your time to do it with the work. Okay? Jaden, as we are looking at this, what is my y sub 2 up here?
3.5. Negative 3.5.
So we're going to put negative 3.5. Hayden minus my y sub 1 is what?
Negative 3.35.
Wait. My y sub 1.
Oh,
So look above where the y is.
6.1.
Right. So when I'm looking at this, this is my y1, this is my y2. So it is important that as you look at those two numbers, that's what that's telling us. So you're writing this down, right? Okay. So minus, we're going to have 6.5. Okay? Now I'm looking at my x sub 2. My x sub 2 would be what, Nikita?
5.65.
5.65. Minus that, and my x sub 1 is?
3.35.
And it is a negative, right? So we have to put minus, and then it's kind of like that negative 3.35. Okay? When I'm looking at that, keeping in mind that anytime we have subtraction, we might want to rewrite this. So if I think of this problem is negative 3.5, it's plus a negative 6.5. So you're going to add that on your calculator. In our denominator, 5.65. Subtraction changes to adding the opposite of negative, makes it a plus 3.35. So in your numerator, Nathaniel, what'd you end up with? Negative 3.5 plus a negative 6.5. Negative 10. In my denominator, Camden, what'd you end up with? 5.65 plus 3.35? 9. This is our answer for our slope, negative 10 over 9. You didn't have to work with it. That's what I'm looking for, negative 10 over 9. So make sure you have your work, the same as my work up here, and then change your answer there, okay? So the reason I'm going through this is I want you to have the right work with it, okay? So if you didn't have it, that's why I'm doing the problem. You have your workbook open? Okay. So, keep it open. So, all of those, the main mistake that I noticed this morning, I had a bunch of people working, is they never put the y's over x's. They didn't label on top here like that this was x1 and y1, and that this was their x2 and their y2. And so when they went to do their formula, every time first off, they weren't checking their answers in the back, and then they didn't make sure that it was right. And you want to make sure that you're practicing this the correct way. So, question 13 says, make a small triangle. So if I was making the small triangle, tell me, Alex, where do you want to make the small triangle from? You want to use 0, 0, or you want to use a different point?
0, 0 to negative 1, down negative 1, to the left to 2.
Okay, so this point at negative 2, negative 1, right? So if we're looking at that small triangle, I'm going to make this triangle. So everyone, if you didn't have a small triangle, please make that small triangle. Okay? So first thing we want to do is we want to find the slope of our small triangle. Does it matter if I make my triangle below or above? No. So you had yours above, like in the pink, or you had it in the blue. It doesn't matter, right? So now that I'm looking at it, Gunnar, that slope of my small triangle. You want to write rise over run. What would your rise be? Looking at this triangle, he gave us the points that we're drawing. Because if you didn't have it done, you're doing it.
1.
So the rise was 1, and the run is 2. So now I need to make a bigger triangle. So Logan, we need to make a larger triangle. Where are you going to make a larger triangle from?
0, 0, and 2 and 1.
Okay, that's going to be the exact same size triangle.
Oh,
I need it bigger.
3 and 1.
3 doesn't go up to 1, but how about if we go over to 4? We can go up to 2. So I could have this triangle, right? So I have another right triangle. So once I have that right triangle, Jeremy, I'm going to put my rise over run again in that larger triangle. What's my rise? Did you draw this one now? Okay, so draw it. That's why we're doing it in class, so you can do this. So draw that triangle that he gave us, going to the point 4, 2. Rise is 2, run is 4, simplifies to 1/2. The question says, are the slopes the same or different? We would answer with they are the same. Why is this the case? And again, if you're not too sure, you can look at what we said yesterday in the notes. Take a look at what's in the back. I'm not going to put that up there, but you can take a look at that, right? The key thing is that those two triangles are both on the same line. So it then asks us down here to do the same thing. Find the slope from A to B. So if I'm looking at this one, okay, Ella, going from A to B, rise over run. What did you have? 3. Positive 3 or negative 3? Negative 3. And my run is 1. Okay? So next I'm going to be looking at it, and if I'm looking at the next one, find from B to C. So if I look at B to C, I'm looking at that one. My rise is?
The rise is going to be 3.
Okay, so rise is 3. Negative 2. So it says, are the slopes the same or different? They are different. And now you want to explain why? Because they are not on the what? Same line. Yes, question.
What you're doing, like, you're reversing the negative.
Does it matter if you have negative 3 over 2 or 3 over negative 2? Is that the same number? When you put 3 over negative 2 on your calculator, 3 divided by negative 2, you get what? Negative 1.5? And you put negative 3 divided by 2 on your calculator, you get negative 1.5. So does it matter if we put the negative in the numerator, out in front, or in the denominator? It doesn't matter. As long as I know that the sign is negative for that slope, and it went down. Okay? Good question. Anyone else? So make sure you have this one done. This is very similar to the stuff you're going to see on the test, where I ask you to compare them and write about the slope. So you'll see this question a few more times. All right, so turn to F7 in your notes. If you didn't finish your F6, you want to make sure you have that done. As you are looking at F7 in your notes, E7, sorry. E7 in our notes. So, today we are going to be looking at slope, and the word that we use, or the letter that we use for slope is M, and that's our unit rate or slope. So those two things kind of mean the same thing. There is the graphing calculators that we could use up here, but we're going to use the online one. So what I want you to do right now is on your calculator, or on your computer, open your computer, and on your computer, I want you to put a tab And you're just going to open a tab, and when you open that tab, you are going to start typing Desmos, D-E-S, and notice when I start typing desmos.com, it comes up with a calculator. You are going to hit enter because you want this Desmos calculator, and it looks exactly like this. Okay? This is the only tab that I would, yep, the Desmos, and it should say just calculator, Desmos.calculator. And yours should look like mine once you put that in.
Why did it show up like that?
Yeah, yours has a keyboard on the bottom. That's because you're ready to start typing in. Okay? Does everyone get this? Okay. In your notes where it says this is where you're going to type the equation, and you can put the color of the line. So you're going to be able to put that, whatever the color of your line is, you can choose that. A lot of times they'll come up with the color in each time. So don't start typing anything yet. You will notice that I give you the origin up here, and it's quadrant 1, 2, 3, and 4. You can click this to minimize your keyboard so that you don't see it. And as you are taking a look, this is the on-screen keyboard. What we are going to be using a lot is we're going to be using the Y and the X over here. We're not going to be using the less than or greater than. So we're going to be using our equal, and then we'll be typing in our numbers as you are looking at that. So as you look at your notes, please, I would like you to go to this page of your notes. So turn to this page of your notes. And as you are looking at this page of your notes, it says using the graphing calculator, or in this case the Desmos calculator, graph each proportional relationship and complete the chart. So the first thing I give you is the function. The next thing I give you is what is our unit rate, or M. Does the line pass through the origin? Draw a sketch, and then compare it. So the first thing we want to do is I want you to go to that calculator, and I want you to put in the equation y equals, so when you go here, when we start typing, so we want to show our keyboard, we're going to put y, you're going to go with equals, and put in just x to start with. Now, your line might be a different color, so if you click along that line, right, and you drag, kind of click and move along that line, what do you notice about every point on that line? About the x-coordinate and the y-coordinate? Are they always the same?
No.
Yes.
Oh, yeah.
So look at our x, look at your y. So click on your line. You just click on it and then drag and move along that, okay? So we're going to notice that. So now we're going to put in equation 2. What is our equation 2? Well, that first one, what was our slope of this equation? Y equals
1x.
So our slope was 1. So right below this in your notes, please put, so in your notes where you're comparing them, please put right below this, m was equal to 1, right? So the slope of that line, you're going to write it right in your notes in the same place where I have it. So you're writing in your notes. You're not on your computer. You're writing in your notes. Y, right here, you're going to put m equals 1, okay? So we're going to put m equals 1 right below that. That was our slope. So now over here it says, well, what's the slope in this equation? So we should write down m is equal to what?
1.
Look at this equation. 2. And now they are going to ask you to sketch that line. So we're going to go back to our calculator, and we are going to put in our second equation, y equals. Now if you just put 2, look at what kind of a line we get. We have to add the x. So this is a horizontal line, right? The slope is 0. And we are going to put in our x. So if we click on this line,
They are not the same.
they're not the same. And what do we notice about our y? It's always double our x. Are all of these points on our line? Look at all those decimals. Are they all points on the line?
Yes.
So it's not always going to be just like the 2, 4. It's not going to be like the 1, 2. So what you need to now do in your notes is you're going to sketch that line. Now, you want to sketch it as accurately as possible. So you don't want to make it really sloppy. But y equals 2x. That means this point, right? Up 2 and over 1, up 2 over 1, down 2. And we are going to draw this line. we were comparing it, it said, to y equals x. So you're comparing it to the red line. So the question says, is it steeper or flatter? Our blue line. And it was steeper. So in our notes, we are going to put it is steeper than that. Right now, what I want you to do, without using your graphing calculator, or without using the calculator, I want you to fill in what these other m's are going down. So m equals here, and m equals this one. And then before you do anything, you are going to, each time, you're just going to put in the new one, so you're going to delete the old point, the 2x, okay? So
leave the y equals x.
So you are going to, each time you put it in your calculator, you're going to leave the y equals x. The reason we want to leave that one is because that's what we're always comparing it to. Okay?
Yes.
So leave, nope, then you can, each time you can erase. So we're going to put in, the next one was 0.5, right, x? And you're going to kind of do a rough sketch of that, 0.5x. So again, mine is blue.
Mine is green.
Okay? And if you want to put like all three of them in at the same time, you can. Make sure when you start it there, starting with the y equals, right? So you want to have your y, you want to have equal. And each time you should do a sketch of those on your paper. So again, you can move points along there, and you can see that that last one. So right now in your notes, you have it circled, steeper or flatter than y equals x. So remembering, our slope here was 1, our slope here was 1. Here our slope was 0.06. And the question was, do each of them pass through our origin?
Yep.
Every single one of them, yep. These are proportional relationships, right? Proportional relationships on our quiz, y equals, this is, please write right below that 0.06, our unit rate. The other thing we have referred that to is we've called it our slope. So make sure you have this with the number in your notes. And I'm just going to wait because some of you still haven't filled in the top part of yours down in your notes. And what do you notice differently this time about the equations? Negative 1. So if you think about our slope yesterday, our slope person, which way should a negative slope be tilted?
Left down.
Should be going down. So here our m is equal to -1. Here our m equals -1. And here our slope is -1. So we're going to go to our equation. And instead of putting 1x, right, we are going to put a -1. We're going to go to our second equation. So it changed that line right away when we put it in. So please put yours in. I want you, before you type in that next equation, I want you to notice when you put y equals and you put the 2, notice this like slider. Does yours come up with this slider?
Yeah.
So if I'm looking at that,
Whoa.
I can change that anytime I click on that to change that line. So, okay. So now I'm going to put, we wanted -2, right? And now we want to have, in this one, we now put the x. But if I click on, let's see, how do I get that slider? I'm trying to remember.
Hit the raise to x.
So put in your -2x, y equals -2x, and then graph those. Same way we were graphing before. So we're comparing it to this line, and we have our y equals, the equation was -2, and then we had our x. And again, you can see all of those points. This was your -2. Each one is like double. So draw those. and we are filling in, does it pass through the origin? What is our slope? Can we write the slopes without going to our graphing calculator?
Yeah.
M in the first one is going to be what, Wally? -2. No x with it, right? If I'm looking at the next one, y equals -4x, my m should be in that one kind.
Your M should be, you want the red one?
This way, right up here, -4x.
Oh, negative option.
And in the last one, Chase.
And it wasn't negative 1.2.
So the first one, was it flatter or steeper?
Steeper.
It was steeper. Okay. So again, as you're putting those in, you're going to put in each one. So we're going to have our y equals, and again, if you don't put the equals, it comes out a little differently, right? Equals, and you have your -4, and you have the x. And then your last one, so that one came out black as a black line for me, y equals, and we are looking at that last one, it was -0.02. Do you think it's going to be flatter or steeper?
Steeper.
The last one, -0.02.
Oh, last one?
That last one, look at that line. It is almost horizontal, right?
Oh.
Which, what do we notice about the slope? The slope is really close to what number?
0.
Really close to 0. So the farther it is from 0, right? One of the things we notice is the line is steeper. So each time I should see these lines. The slight slope of -2, I can tell that that's going to be going 2, like this. The slope of -4, that means it's up 4 and over 1, down 4 and over 1, okay? And again, we said steeper and steeper, and this last one was much flatter in that what's happening is that if I move, what this is telling me, if I move 1 unit over, if I move over a whole unit, I only went down 0.02. That's what that slope tells me. This slope tells me as I move over 1 unit, I went down 4 units, right? This one tells me as I go over 1 unit, I went down 2. That's what the slope. This one tells me I'm only going down 0.02. I'm hardly going down at all. So it's almost like a horizontal line. So please turn to that next page in your notes. And it says, what point does every graph in problem 1 have in common? They all had the origin or 0, 0. So please put both. Origin 0, 0. So it says the graph that lies in quadrants 1 and 3. The m value is what? So going back to this page on your notes, I want you to just number your quadrants going around. This was quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. And they're always in Roman numerals, okay? So when you are taking a look at those, please in your notes put quadrant 1, 2, 3, and 4. Do it on the first one of that, on that problem 1, and then go back up to the top one, and up here, let's put those quadrants also. Because this one says, in this problem 1, this first one, when do you have, this is quadrant 1, this is our 2, this is 3, and this is 4. So when we answer those questions now, it says, what lines lie in quadrant 1 and 3? Then the m value is what? So what is our m value when it's in quadrant 1 and 3? Should be always positive. Okay? Does that make sense to everyone? If you look at those first 3 that we did, the m was always positive, quadrant 1 and 3. So if it's going to be in 2 and 4, what were our m values? Turning to that next page. Our m values were always
Negative.
negative. It says if m is positive, as m gets farther from 0, what happens to our number? So if I have 2x, 5x, 10x, what happens to 10 compared to 2? It gets steeper, right? So the farther it is from 0, the steeper it is. So the line gets steeper is what you want to write down. So some of you haven't started writing on this last page for your notes, so fill those in. The next one says, okay, so now If m is negative, predict what happens as it gets further from 0.
It's flat.
-2, -4, if we are looking at that, that is still going to be much steeper, right? So we're still going to say that it's getting steeper. It then says, well, what will the line look like if it is an m value of 0? If m is 0, what happens? It's flat. Like how flat? Like flat which way? Like horizontal. And could we check that right now? Could we take a look at our equation and put in, right?
Yes.
Let's put in 0. Oh. Instead of it being 1, let's put in 0. So if the slope is 0, it's a horizontal line and it's right on top of that x-axis, right? So when we are taking a look at it, when we have a slope of 0, what happens? Horizontal line. And our horizontal line, if the slope is 0, is actually going to go through, it's going to be on top of the x-axis. Okay? So it says, summarize, what is the role that m plays in our equation? M tells us the what of the line. What does the m tell us, the what of our line? What were the 2 words we were circling at the end of each of those? The what? It does tell us unit rate, but what are the 2 words that we were circling behind all the graphing ones? It tells us the steepness or flatness of our line, right? So when we are taking a look at, anytime we look at that m, the m is going to tell us that m affects the steepness of the line. This is what I want you to write down. M affects the steepness of the line or the flatness of the line, right? The closer the number is to 0, the flatter the line is. The farther the number is from 0, yes, Stephen, you can take your notes out and just start filling in from where we're at. The further the number is from 0, the steeper the line. Meaning that if I have y equals 2x, and I compare that with y equals 7x, this line will be steeper, right? This equation, this line will be steeper than the y equals 2x. Okay? If I'm looking at my flat lines and I have y equals 0.5x, and then I have y equals 0.003x, this line is going to be really flat. It's almost horizontal, right? This is really, really flat because it's really close to 0. It's much flatter than this one of 0.5, okay? So we got one more section of our notes that we want to look at, but I want to make sure everyone has that m effect, so that the m affects the steepness in your lines. So in that box is where you're writing that down. M affects the steepness of our line. The closer the number is to 0, the flatter the line. Farther from 0, the steeper it will be. An equation for a line that fits this. It has to be a straight line in quadrants 1 and 3, and it's going to be steeper than y equals 2x. So I want you to come up with an equation. The next one, a straight line that goes through 2 and 4, and I want it to be flatter than 0.3x. So using the information we just talked about, right down here, right? When do we know a line is flatter or steeper? I want you to come up with your equations as you are looking at that. So there's many right answers for this, right? So start writing your equation. It's going to be y equals with your slope. This next one says a straight line between 3.1 and 0.5. And then the last one is for a straight horizontal line. So I'm going to let you start writing. You need to write some down before I put mine up. I'm not going to pick line that is flatter than -0.3. So give me your answers, Nikita. I'm looking at y equals -0.1. Did you have an x with it?
Yeah.
Yes. -0.1. You said, right? Not 0.1. Not 0.01. 0.1x. Another one. Alex. Andrew. Good job. Alex, sorry.
-0.2x.
-0.2. Can I have any number as long as it is less than negative 0.3? Yes, so anything that is less than, so y equals a negative 0.002x, right? That's going to be flatter. In this next one, what do I have to know that the number has to be in between what two numbers? 0.5 and 3.1. Logan, give me one answer.
Y equals 2x.
2x. Gunnar, give me another answer.
3x.
Y equals 3x. Give me another answer if we are looking at it,
Okay.
Robert. 2.5x. Anything, so as long as it's between. Horizontal, if we are looking at horizontal. What kind of line is horizontal? Y equals 0. Try on your calculator, y equals 2. So on your equation, we just put in y equals 2.
It's just flat.
It is another flat line, right? So it doesn't have to be 0. What has to be the case is we just have to have y equaling a number. So y could equal 4. Notice if I move this, right, it's always going to be a horizontal line, right? So anytime I'm looking at that, as I look at my equation, a straight horizontal line, as long as there's no x with our equation. So now it says for this last one, write an equation for this line down here. So you're looking at this point. Is it a positive or negative slope?
It is a
Positive.
So again, if it helps you to think of the slope person, positive, this is a definite negative slope, right? It went down. How far are we going down before we go over 1 unit? Down to
Over 1.
over 1, so negative 2x. Your homework is just 1 page of E7.
Yeah.
You are asked to first identify the slope. Does the slope ever have an x with it? Does the slope ever have x with it? Yes or no? No. Slope is simply a ratio. There is never an x with our ratio. Okay? Slope is simply a ratio. Okay? This next part tells you you're looking at this part. $4,000 for 4 hours. Find the slope or the unit rate. You've done this. I am